1, 2, 3, record. Now, in our attempts to prepare you for California College and to deal with some of the problems that you will see, I'm going to derive the derivative for a few things so that I can show you the algebra that your calculus professor would really like you to know, so that you can do it an easier way and he will be proud of, she will be proud of you. Okay, y'all know in order to do the derivative by the limit definition, that's what we're talking about here. We're going to do limit definitions. I know there's a shortcut formula. Your professor knows there's one, but when you're taking Calc 1 for the first time, you're not supposed to know those are there. All right? Now, don't ever raise your hand in class and go, why don't we just use the shortcut formula I learned in high school? Bad. Why don't you just take Calc 2 is going to be his answer? Or can you prove the first one? But here's the deal. Here's what you do. When he's doing these things, and he's doing it using the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, and he's using this formula. And if he's used this formula for 2 or 3 days of class, and he's even started like working the really elaborate calculus, still using that formula, don't raise your hand and go, can I use the shortcut formula from high school? No, no, no. You raise your hand and go, Dr. Butler, I was reading the book last night, and there's some shortcut formulas for that, aren't there, in the book? I think I found some shortcut formulas in the book, but I didn't know if that was really what we're doing right here. And he's going to go, oh, yes, I guess I'll start using those now that someone has opened the book and looked at the book, and he'll start using them, okay? But please don't tell him, can you do something you did in high school? Tell him you read it in the book. At least know what page it's on in the book. Say page 73 or whatever. Now, but here's how you do this. The way to substitute, you're going to substitute into this formula. That's the limit formula for derivative. Before you do any of it, go over here. There's your f of x. What will make this a lot easier is if you'll go ahead and write what f of x plus delta x equals before you ever start it. Just write what that equals. And the easy way to do that is when you have f of x, now you got what? F of what? X plus delta x, right? So everywhere that there's an x in here, you're going to have to put in what? X plus delta x, right? Substitute it in, so you get x plus delta x cubed. But if you'll always write this up here, sometimes I always tell students to write below it, beside it, somewhere, because this is the part that you're going to substitute in here, and then there's your x cubed going to go in there. That way you don't make a mistake if you try to put it straight in here. Helpful? Somebody shake their head with some kind of expression of helpful or... All right, now, so I put that information into the formula. Limit. Delta x approaches 0. X plus delta x cubed minus x cubed over delta x. Now, I picked out the cubed ones to work for y'all today because I think if you have the square ones, if you have this squared minus this squared, you know to use the difference of two squares to factor it, right? The problem here is you got the difference of what? 2 cubes. If you multiply this out and you do x plus 3 times x plus 3 times x plus 3 and get this really long polynomial, it will work. But when you do that, your professor will just shake their head wondering why you did not learn any algebra. Because that's the hard way to do it. You don't want to sit there and multiply all this out and use that F word to get that. Here's what you want to use. A cubed minus b cubed will factor. And it will factor into a minus b, a squared plus ab plus b squared. And by knowing that factoring rule, you can go from here and in 2 steps be done. But if you don't know that factoring rule, then you end up filling up the whole board and wasting a lot of time. Okay, there's the A. That's your A, right? And that's your B. There's your A. There's your B. So we're going to put it in the formula over here, and I'm just going to put it right here in the formula right here. Limit as delta x approaches 0 of x plus delta x minus x. There's your A minus your B. Then I'll put x plus delta x squared plus, and I'm going to change the order. I'm going to put the x in front of the x plus delta x. So I did b times a plus x squared. So there's your a minus your b.
You don't need the exponent
Where?
on the x cubed. I think this b is x cubed over here. You use the exponent over there.
Yeah, it's just b squared.
Okay. Oh, so I got you.
Yeah, it's a minus b. There's a minus b. Yeah, the cube is not part, the little 3 is not part of your b. Is that okay, the exponent?
Mm-hmm.
And then you get a squared plus ab plus the b squared. All right, is that okay? Make sure I wrote it down where you can read it. And then you have the delta x in the denominator. Now, when you were doing these earlier this year, you hopefully were just overly told that delta x in the denominator has to divide out. That's the only way these will ever work, is if that delta x divides out. All right? Look what happens right here. What's x minus x? 0. What are you left with? Delta x. And the catch is, you got to that without having to do a lot of hard math, because you used the part above you. And I'm going to go ahead and write in a step that you would probably skip. I wanted to skip it, but I'm not going to. I want my students to know what they're doing when they get to calculus next year. And notice, the delta x's will now do what? Divide out. Once that delta x divides out, you can make delta x equal 0 and see what happens. So now, make delta x equal 0. Okay, you put a 0 there. And what's going to happen? You're just going to get what? X squared. Put a 0 here, you're going to get x times x, which is still just going to be what? X squared. And there it won't matter. So you find out that the derivative, f prime of x, equals 3x squared. Now, let's think about the process. When you're proving using this formula, you've got to reach a point where that delta x divides out. That's the whole key right there. And then once that delta x is divided out, you can make delta x equal 0, and you're going to get the results. Now, the part that I wanted to show you today is, if you use the cube rule, you just saved yourself a whole bunch of work. Because see how easy it was to get rid of the delta x, divide it out? If you'd have cubed it, you would have had an expression with four terms minus another term, you'd have had a big old long polynomial up there you had to work with. And we don't want that. We want to use that cube rule. So far, so good. Questions before I move on? Because I don't want to go too fast. I want to make sure you're happy. Are we happy, as Samuel L. Jackson would say? Are we happy? And Vincent said, we're happy. Okay? All right. Well, we're going to do another one. And this one is going to involve a cube root. Now, if it involves a square root, you multiply by the conjugate. Square roots, you multiply by the conjugate, and you can probably already do that. But let's talk about what happens if it's a cube root. And I'm going to use a power of 1/3, but you could have a cube root radical. F of x equals x to the 1/3. All right, we're going to talk about what you do when you have a cube root. Notice I'm leaving that formula up there. Yeah. Someone says he kept telling us in pre-calc that we'd need it. All right. So to make it easy to do my substitution, let's go ahead and write what f of x plus delta x equals. It would equal x plus delta x to the 1/3. Is that all right? Then let's substitute it into the formula. Limit as delta x approaches 0 of x plus delta x raised to the 1/3 minus x to the 1/3 over delta x. This is the problem that if you've not seen someone do it for you, or someone's not giving you the big hint, it would be really difficult to do. This is the one that would show up on an exam to tell some people that they weren't going to make an A, maybe. Okay. Walk over here. A to the 1/3 minus b to the 1/3 times a to the 2/3 plus a to the 1/3 b to the 1/3 plus b to the 2/3 equals a minus b. That is the cube rule, but you don't start off with a cubed and b cubed. You just start off with a and b. All right? So a minus b factors into all that. Now, it's an adaptation of the cube rule. Notice, I took the cube root there, right? Cube root there, cube root, cube root, cube root. And when I multiply those together, instead of getting a cubed minus b cubed, I just get what? A minus b. This is the rule that you have to know, memorize, have it written down, or you can't do this problem. And it's one of those rules that nobody ever gives you. All right? So write it down, put big stars by it, because that's how you deal with cube roots. Anytime you're trying to prove the derivative for a cube root, you're going to have that formula right there. Because it tells you this little citizen bit information right here. I'm about to use that. Because what I'm about to do is I'm going to multiply by x plus delta x to the 2/3 plus x to the 1/3, x plus delta x to the 1/3 plus x to the 2/3. Now, if I multiply by that in the numerator, I must multiply by the exact same thing in the denominator. Mr. Reese is back there pointing denominator. Yeah. So I do that. Don't multiply at your denominator. Because what you're hoping that delta x divides out right there, aren't you? Yeah, we're hoping it goes away. All right, so I multiply out the numerator. And do I really have to I used the F word in class. On video, I used a 4-letter F word. When you multiply out the numerator, you don't have to multiply it out because you already know what the results are going to be. They're going to be what? A minus B. That's the reason right there we know that's going to make what? A minus B. So we get limit as delta x approaches 0 of x plus delta x minus x. There's our numerator, a minus b. And then the denominator we have delta x, parentheses, x plus delta x to the 2/3 plus x to the 1/3 x plus delta x to the 1/3 plus x to the 2/3. And look what magically just happened. What's going to happen here? What's the only thing we have to have left here? And then that delta x and this delta x are about to do what? Divide out. So you'll get limit as delta x approaches 0 of 1 over x plus delta x to the 2/3 plus x to the 1/3 x plus delta x to the 1/3 plus x to the 2/3. Now, what can you do once the delta x is divided out? What do you do next? Once the delta x is divided out, what do you do? Plug into 0. Make delta x equal 0. Once you get it divided out, make delta x equal 0. And when you do that, you will get x to the 2/3 plus, you're going to have x to the 1/3 times x to the 1/3 plus x to the 2/3. And I bet everyone here knows that becomes x to the 2/3 plus x to the 2/3 plus x to the 2/3. So f prime of x would equal 1 over 3 x to the 2/3. And those are special problems. I don't think your professor in college is ever going to ask you an x to the 5th. He might do an x to the 4th, because if you know how to factor x to the 4th, x squared plus 1, x squared minus 1, and then factor the x plus 1, x minus 1 after that, and you factor it down, it'll do the same thing as this. You don't have to multiply it out. All right? This is going to work for any cube root system that you have. If this were x plus 3 all in parentheses cube root, this would still work. You know, x plus 3 plus delta x, and it'll all work. Okay? But this is what you always have to multiply by. You've got to know that little trick right there. A to the 1/3 minus b to the 1/3. In order to make it workable, multiply by a to the 2/3, a to the 1/3, b to the 1/3, plus b to the 2/3. So put this one in your notes and realize if you're trying to prove cube roots using the limit theorem, you got to do that. Somebody says, Mr. Evans, I'm not going to do that in college. I'm just going to write down the answer. And your professor's going to circle where it says prove with the limit theorem and put a 0 down there. Okay? Or a frowny face. Know this. All right. Well, I did those because I wanted to show you two that I know you're going to see on tests and in college, where you have to use the cube rules. Then, this morning, I showed the students, and I couldn't get my recorder to work, I showed the students how to prove the first derivative rule that you learn when you're learning just the rules. And we're going to talk about how to prove that rule, because that is one of those, let's put a question on a test, last question on your first calculus test, prove, and it'll have you prove one of the derivative rules. And I'm going to prove 2 or 3 of them over the next couple of days. But we're going to do the very first one. All right. What we want to do is if f of x equals x to some power, we know that f prime of x is equal to whatever that power is, x to the n minus 1. And we know that's the rule. We just used it twice. The 2 problems that we just did, you could have used this rule and done them real fast, right? You already knew what the answers looked like before you started because you already knew that rule. We want to prove that rule works. We want to make a proof for that rule. Okay, yeah, I'm looking at people's faces and they're going, at least I don't have anybody here going like I had second hour. Why would we bother why would they tell us to prove stuff? To make you think at a deeper level.
That was me.
That wasn't you, that was,
That was me.
that was.
It's okay.
It's all right, do you think that, did you like my answer?
Yep.
See, I like that, you like my answer. All right. Now, probably just because we want to laugh at y'all, is really why we do it. You know, we just want to laugh when we...
It was a real question. Like, I was just wondering, like, if we can do that, why is it necessary to prove the...
Oh, I agree. Yeah. There's 2 reasons. One is to think at a different level. That's the answer that I should give because it is all very education and let's be proud of learning more. And then the second answer is your professor loves to see you fall asleep during class so he knows he can fail you without any problems. All right. We're going to prove it. If we're going to prove it, here's what you have to do. F of x plus delta x. That means everywhere there's an x, you're going to put in what? X plus delta x. And you get that. And then you put them in your limit rule. Anytime you're proving these derivatives, or a lot of these derivatives to prove, you're going to need your limit rule. So we're going to do limit. As delta x approaches 0, of x plus delta x raised to the nth power minus x to the nth over delta x. And if I were having to prove this when I was in school, as lazy as I was, and you see where I ended up, so you may not want to do that, I would have made sure it was real easy for them to read that, and then I'd have just scribbled all over the page and put, you know, what I was trying to prove down there. It's not how you're supposed to do it. Okay. Well, let's talk about what's called binomial expansion. Yeah, I taught this in pre-calculus to my children, and I said you'd only need to know it to do one problem in calculus. Here it is. A plus b raised to some power. The first term is always a to the n, b to the 0, and I'll go ahead and tell you the good news. That turns out to be a 1 right there. Plus, and y'all realize the power above the a goes down by 1. Is that okay? Think about if you have x plus 2 cubed. The first term is x cubed, right? Okay? So, and then it goes down by 1 power, but the b value has to go up by 1 power. I'm leaving a blank right here. We'll come back to fill in that blank. B to the 1 power.